5.4. Again, we missed you guys all in class today, so hope you all are doing well that are at home. And this section, we're going to keep learning about different ways to find the center of a triangle. Remember, we don't have one way that we define center of a triangle, but this is going to go over the two last ways that we're going to learn to find the center of a triangle. So let's switch over to Paint and let's get started. So if you remember, we've been talking about ways to find the center of a triangle, and the two ways that we've talked about so far, I have down here. We've got the circumcenter and the incenter, and we're going to learn something about the centroid and the orthocenter. And so how we've kind of been talking about is that we usually learn a term, and then that term helps us to find one of the centers of the triangle. So we're going to continue that pattern on, and I'm going to draw a triangle, and we're going to learn another new term. So the new term that we're going to learn for the next center of the triangle is something called the median. Oops, if I can talk right, if I can get this working right. Hold on, give me a second. There we go. So we're going to talk about finding the medians of triangles. All right, and this is on your notes. So basically finding the median of the triangle, if this is triangle A, B, C, okay, triangle ABC. If we want to find the median of the triangle, what we're going to do is we're actually going to find the midpoint between the two vertices, right? So this is the midpoint, and we're going to draw a line from the midpoint to the opposite vertex. This. So this blue line that I just drew is a median. MC is a median of triangle ABC. All right. So median is kind of a little bit like the perpendicular bisector, except it's not perpendicular, right? It's not perpendicular. So oops, didn't mean to go back that far. It's not perpendicular, so it's not like the perpendicular bisector. It comes from the midpoint, but it goes to the opposite vertice. The one thing that we do know, though, right, is since that's the midpoint, then these two line segments are congruent. All right, so let's keep doing this, and we're going to draw the medians for the other two sides of the triangle. So we'll say the midpoint's about here, and the midpoint of AC is about here, and I'm going to draw the medians there. So if I have the midpoint of BC is right here, and I draw a line to the opposite vertex, which is A, and then I've got the midpoint down here. I draw a line to the opposite vertex, which is B up here. So what you'll notice when I did all that, M, N, O, and we'll call the center point P. Hey, guess what? When you draw the medians of the triangle, they also end up in a point somewhere in the triangle. And this center of the triangle, this new center of the triangle, has a special name, of course, and we call this the centroid of the triangle. Okay, so that's the next new thing. So now we have the circumcenter, the incenter, and now the centroid. So the centroid is made by using the medians of a triangle. So this one's a little bit different because we don't really have to use angle bisectors to find the point that's equidistant from the sides, right? We just have to draw the medians and we figure out where the centroid is, and that's pretty much it. So we know where the centroid is just by finding the medians. So it's a little bit easier in that aspect, right? The other interesting thing about the centroid that makes it different from all the rest is that the centroid is actually the center of mass. So if you could imagine, if I could pick up this triangle and I could balance it on my pen, right? The point that I would want to balance the center of mass is at the centroid. So that's why this is important. And if any of you are in conceptual physics, at some point you'll be talking about the centroid, finding the center of mass for your triangle. Okay, so there is one theorem that goes along with that. And I'm going to tell you about the theorem, and then we'll go down and write it in. So some really smart mathematicians a long time ago discovered this idea of the centroid, the center of mass, and they discovered a relationship between the lengths of the medians. And what they discovered is that if they measured the distance from A to N, they measured the distance from A to N, and they measured the distance from A to P, so to the centroid, so just A to P here, that the distance from A to P was always equal to 2/3 of the distance from A to N. So it's kind of weird, kind of cool, right? It's always true. And they noticed this pattern for all of the sides. So the distance from B to P, the distance from B to P was always equal to the distance of 2/3 of B to O all the way across. And the distance from C to P, right here, is always equal to the distance of C to M, all the way, 2/3 the distance of C to M. Okay, so they noticed this pattern, and guess what? Because of this pattern, then we have a theorem that has to do with centroids. And that theorem is the congruency of medians of a triangle. So this is a triangle where the medians have been drawn. Right here are the three medians. And it's the same idea. It says the medians of a triangle intersect at a point that is 2/3 of the distance from each vertex to the midpoint of the opposite side. Okay, so it's a lot of words, right? But basically it's just what we talked about. A to P is equal to 2/3 of A to E. You know, B to P is equal to 2/3 of B to F. And C to P is equal to 2/3 the distance from C to D. So the whole distance. So practically what that means is if I said to you, we got a lot of going on in this picture, right? But I said, hey, the distance from A to N, is 15. So if I go all the way across here, I know it's 15 units, right? And then I said, hey, could you tell me what the distance then is from A to P? Okay, well, the distance from A to P is always 2/3 the distance from A to N. So 2/3 of 15 is 10. So the distance from A to P is 10. And then what happens if I want to know what is the distance from P to N? So the whole thing is 15. From A to P is 10. That means from P to N has to be 5. There's two ways you could figure out this 5. You could either subtract 10 from 15, right? The whole thing is 15. Part of it's 10, so that means the other part has to be 5. Or you could say, well, if this part is 2/3 of the total, then this part would have to be 1/3 of the total. So 1/3 of the 15 to figure that out. All right, so that's what's going on with the medians and finding the centroid. Again, centroid's an important one because it is the center of mass. So I'm going to scroll down here to our chart that you should be filling in. And the centroid is created by medians. Right? A median is created by a blank connected to the blank of the opposite side. So it would be a vertex connected to the midpoint of the opposite side. So if I wanted to add some notes down here, I would say, okay, that is theorem 5.8. And I would also say you might want to add a note just to remind you. Don't have to do every single one, but you could remind yourself, oh, well, I know this is a median, right? So the distance from A to M is equal to 2/3 the distance from A to Y. And if you wanted another example, you could say the distance from B to M is equal to 2/3 the distance from B to Z, and so forth. Okay, so one more to go, and this one's a pretty quick one. This one, so that's the centroid. And again, one other thing you might want to add in here is that this is and I ran out of room at the bottom, but you could write it at the bottom. This is the center of mass. And since it's the center of mass, it's always going to be inside the triangle. Remember how sometimes our again, you don't have to write on top of this, but remember how sometimes our center of the triangle is outside? Well, for centroid, it's always going to have to be on the inside, especially if that's where the point you're going to be balancing on. All right, the last one, again, we kind of have this pattern. We learn a new word and then we apply it. So we have one more term to learn, and that term is the altitude. The altitude. So when I asked the students in class today if they knew what the altitude was, a lot of people were like, not quite so sure what the altitude was. And I said to them, you actually know what the altitude is, you just didn't know that you knew what the altitude is. So the altitude is kind of like the median, kind of like the perpendicular bisector. So what the altitude is when you take the, oops, didn't mean to do that. Go back to black, there we go. When you take the one vertex, and you go to the opposite side and you meet the opposite side at 90 degrees. I'm having all kinds of trouble with that guy there. Okay, there we go. All right, I think we're good. So the altitude is when we go from one vertex, one vertex to the opposite side at 90 degrees. Okay, so at 90 degrees, that's the altitude. So it's kind of like the perpendicular bisector because it's got 90 degrees, but it doesn't divide your line, your side into two equal parts. So it's not like the perpendicular bisector in that way, right? So this is an altitude. And what I've told my students is you've actually been doing altitude your whole life, because let me draw the altitude for this side over here. When I draw this altitude over here, this altitude would look something like this. You'll notice the altitude is outside of the triangle, right? Feels a little bit weird. The altitude is outside of the triangle. The blue line is the altitude. And does this remind you from all those times growing up when you were learning about how to find the area of a triangle and you learned the area of a triangle is 1/2 base times height? And sometimes your height in those problems was outside of the triangle, and it always felt kind of weird, right? Well, guess what? Your height is the altitude. So you've been using altitude all these years when you were finding the area of a triangle and you didn't even know it was altitude. So the altitude is what happens when you measure the from one vertex to the opposite side at 90 degrees, and the altitude can be outside of the triangle. It doesn't necessarily have to meet inside of the triangle, which means that when I find all three altitudes together, I find a point at which they all meet. And the point at which all three altitudes meet is called the orthocenter. So the orthocenter is where the three altitudes meet. There we go. Three altitudes meet. Now, my drawing is not that great because I'm not doing a great job with my altitude, but I'm going to cheat a little bit and I'm going to scroll down here to my theorem. So in this theorem, you can see that they've drawn the three altitudes of this triangle. For example, CE goes from C to line GB and it meets at 90 degrees, right here, and it meets at 90 degrees. So that's one altitude, goes from G to line CB and meets at 90 degrees, and from B to GC and meets at 90 degrees. So we've got our three altitudes that are drawn there much better than I have done. And when we do that, we have a point where they all meet and we call that the orthocenter. Now, the theorem for this is pretty underwhelming, okay? So the theorem for this says the lines containing the altitudes of a triangle are, and the fill-in is concurrent. And I think that might have two R's, concurrent, maybe, I don't know, or concurrent. So basically all that theorem says is that when you draw three altitudes, that they meet up at a point. That point could be inside your triangle or outside your triangle, depending on what kind of altitudes you have. So I think orthocenter is kind of like the easiest one, basically. All right, so last thing we got to do is fill in our charts for this. So the orthocenter down here is created by altitudes. It's created by the altitudes. And an altitude is created by a vertex connected to the opposite side so that it is perpendicular to the side. Okay, so basically, and we know when those three go together that they meet at a point that's concurrent. They just meet at a point. So last thing we got to do to fill in our chart is put what theorem that is, and that is theorem 5.9. All right, so now you should know the 4 ways that we can find the center of a triangle. I hope that helped. Probably the trickiest part of this with the centroid is with the 2/3 fraction. So just be really careful about which parts that you're using for that when you're doing your homework. So that's all, guys. And let's see if I can turn it off. There we go. I hope you guys have a great weekend.